The complex exponential in chapter 1. What is complex exponential? You see the definition. If z is equal to x plus iy, then e power z. E to the power z. Here z is a complex number. Is defined to be the complex number. E to the power z is equal to e power x multiply cosine y plus I sin y. This is the complex exponential. Okay, how we write this? You see here, you see the note e power ix is equal to cosine x plus I sin x. This is nothing but Euler's formula. Now e to the power ix is equal to cosine x plus I sin x. This is Euler's formula. We have to apply the Euler's formula here. You see how e power z. Now e power z. This is here e power z is equal to e power. What is z? Z is nothing but the complex number of the form x plus iy. So you put here x plus iy. Okay. Now here base is e, the degree is x plus iy. So we have to separate it. So e power x multiply e power iy. Now you keep e power x as it is. Now here e power iy is nothing but by Euler's formula. I can write e power iy like this. E power iy is nothing but cosine y plus I sin y. So that e power x multiply cosine y plus I sin y. So that this is the complex exponent form. That is e power x. So that is e power z is equal to e power x multiply cosine y plus I sin y. Okay. Now similarly here, what is e power minus z is equal to? Similarly, you do the same procedure, then you will get e power minus x cosine y minus I sin y. Now, already we know that z equal to a plus ib is a Cartesian form of the complex number. Now, what is polar form? That is z equal to r cos theta plus I or sin theta is equal to r, if you take as a common factor, that is cos theta plus I sin theta. Okay. Now, here, what is this? Z, see, we are writing here this form as z is equal to, what is r? R means nothing but modulus of z. That's why we are writing modulus of z here. Then what is cos theta plus I sin theta? From the previous result by Euler's formula, this. So that here cos theta plus I sin theta, we can write e power I theta. So z is equal to mod z e power I theta is nothing but the polar form. Now that is here z equal to r e power I theta. Now z bar is equal to, what is that? A minus ib. Similarly, we can write this is equal to r e power minus I theta here. Because here we take complex conjugate, that's why here r e power minus I theta. Conjugate means here to change the symbol of the imaginary part. So that here we write e power minus I theta for z bar. Okay. And these rules we can use whenever we need to simplify some constraints. Now, write each of the given numbers in the form of a plus bi. Okay, now this is the given number. So we have to write this number in the form of a plus bi, the simple form of the complex number. We have to write here. This is a complex number, but not in the form of a plus bi. Okay. Now, first you take the numerator. E to the power 1 plus I 3 pi is equal to, now here base is e, so e power 1 multiply e power I 3 pi. Now here apply Euler's formula, so cosine 3 pi plus I sin 3 pi now is equal to e multiply, what is cosine 3 pi? You see in the calculator or use the previous table which is given in the previous video. So cosine 3 pi is minus 1 plus I times sin 3 pi is 0. So you simplify it, you will get minus e. This is the value of the numerator, this one. Now you find the value of the denominator separately. Then finally we can substitute both in the given expression. Now e to the power minus 1 plus I pi over 2, that is in the denominator. So now again you separate this. So e power minus 1 into e power I pi over 2. Now apply the Euler's formula here. So now e power minus 1 cosine pi over 2 plus I sine pi over 2. So this equal to e power minus 1, this is 0 plus I, this is 1. So now e power minus 1 into I, this is the value of the denominator. Now substitute this one and this one, denominator divided by numerator divided by denominator, substitute here, so that you see here minus e divided by e power minus 1 into I. Whenever you have any complex number in the denominator, you have to take the conjugate of this, you have to multiply. You see here, we have seen in the first week. What is the conjugate of I? That is minus I. So minus I, multiply in the denominator, numerator, and then remaining you keep it same. So that now here minus this minus. How e become e squared? Now e power minus 1 in the denominator, this will come here, then multiply with this, so that minus e square divided by this I here, then this is the conjugate of this I, so that I can multiply in the numerator and denominator, so that you will get final answer I e squared by 1. Okay, now final answer is I e squared. So this is the simplification of this one. So now what is the question? A plus b, you write the given expression in the form of a plus bi. Now what is here? I e squared. Actually this is a plus bi form, because e squared is nothing but some value you can find in the calculator, I think 7 point something. So this is in the complex number form. Now you see the second question, e power z, where z equal to 4 multiply e to the power I pi over 3. Now what is z? This one. So that now first we have to expand this, we have to find the z. Okay, now e power I pi over 3. What is e power I pi over 3? Now expand this, then you can find the complex number. Now this is the value of e power I pi over 3. So what we have to do, in the z you substitute this one. So now what is z? Therefore z becomes, you see here, therefore z becomes 4 times this 4, and then this value here, right? Now 4 multiply inside, so this is your z now, this is your z now. Actually the question is, what is e to the power z? This we have to find. So now for that, first we have to calculate z. So we have calculated z. Now you go to find e power z. So e power z is nothing but e power, substitute z here, so that now e power z is 2 plus I 2 root 3. Now again you substitute this, then e power I 2 root 3. Here you apply the Euler's formula. So cosine 2 root 3 plus I sine 2 root 3. Now here this equal to e power 2, here cosine 2 root 3. E power 2 you multiply, you distribute e power 2, so that you will get this. Then you make use of the calculator to find e squared. What is e squared? And then what is the cosine value of this? Keep your calculator in the radian mode, because here 2 root 3 the number. So radian mode, and find the value of cosine 2 root 3, then multiply it. You will get minus 7. Similarly, put your calculator in the radian mode, find the value of sine 2 root 3, then multiply with e squared. You will find this value. Okay, so this is nothing but the form of a plus bi. So that we have completed the value of e power z in terms of a plus bi. Now, what is the next question? Here we have to find, we have to show that for all z, e to the power z whole complement is equal to e to the power z bar. That is complex conjugate bar. We can say bar, complex conjugate. Okay, now we will take left side, LHS, that is e to the power z whole bar is equal to e to the power, what is z? Z is nothing but x plus iy. This is the general form of z is x plus iy. So put z equal to x plus iy, then separate e power x multiply e power iy. Now you apply the complex conjugate, that is e power x. What is this? E power iy is nothing but, by the Euler's formula we can write cosine y plus I sine y. Put conjugate for all. Now apply the conjugate. Here no complex number, so write e power x as it is. Now here, this is a complex part, imaginary part. So you have to change the sign. So cosine y here minus I sin y, because here we have bar. So we have to take complex conjugate. That's why I changed the sign here. Okay, I changed the sign here. So e power x cosine y minus I sin y. So now e power x cosine y minus I sin y is nothing but e power minus iy. So that I can write e power x e power minus iy. So e power x e power minus iy, you combine these two, so that you will get is equal to e power z bar, because z is x plus iy, because z is x plus iy and z bar is x minus iy, so that is equal to e to the power z bar. That is your right side. That is your right side. So that we have proved this one. Now we'll go to another theorem, de Moivre's theorem. So now what is this? Is it, suppose the complex number is of the form, in polar form, z is equal to r cosine q plus I sine q, then suppose you take the nth power of z power z to the power n, then we have to write is equal to r to the power n cosine, you have to put this n inside the angle, so cosine nq, you see here cosine nq, here sine nq. So that now if z is equal to r cosine q plus I sine q, then if you raise the degree of z to the power n, then this is the result. This is the de Moivre's theorem. So now write 2 cosine 20 degree plus I sine 20 degree whole to the power 3 for all whole to the power 3 in the standard form a plus bi. Okay, so now apply the de Moivre's theorem. What we have to do, apply this degree 3 to 2, number 2, so 2 power 3, and then you see this part, so what you have to do, apply this number 3 inside the angle. So now cosine 3 multiply the angle plus I sine 3 multiply the angle. So now 8 times cosine 60 degree plus I sine 60 degree. So that now you can see this in the calculator, value is 1 by 2 plus I root 3 over 2. So now this is the answer. This is the form of a plus bi, a 4 b 4 root 3. Similarly, write 1 plus I to the power 5 in standard form a plus bi. Okay, how to write this one? Okay, now here this is the Cartesian form. So now first we have to change it to the polar form. To change it to polar form, first we have to find modulus, that is root 2. Then theta is nothing but pi over 4. Here the number is in the first quadrant because both are positive. So that in the first quadrant, theta is nothing but alpha is this one. So that pi over 4 is the value of theta. Okay, already we know that that's why I'm telling simply. Now, so r is root 2, theta is pi over 4. So we have to write the polar form first. That is root 2 r, what is here, cosine theta plus I sin theta. Then apply 5 because here the complex number to the power 5. So apply 5. So now degree 5. So put this degree here by de Moivre's theorem. So root 2, put the degree here. Okay, here. Then when you come inside this one, put this 5 with the angle. So cosine 5 pi over 4 plus I sine 5 pi over 4. So now what is the value of this one? You can see in the calculator. What is the value of this one? You can see in the calculator. Keep your calculator in the radian mode. Then these are the values from the calculator. If you distribute 4 root 2 inside, so this is your answer. So this is the answer of 1 plus I whole to the power 5 by using the de Moivre's theorem. Okay. Now, whenever you get time, you try how to find sine 3 theta is equal to 3 cosine square theta sine theta minus sine cube theta, and this one also. How to find this? By using the de Moivre's formula. Whenever you get time, you try how to do this. And I posted practice set questions in the Blackboard. You download and you practice that also. Thank you.